Okay, final lesson for this week will be over similarity and dilation. So when we see the word similarity, we need to think different size, but same angles. Okay. So up here, we got triangle DEF, so that's the top triangle. And then that is similar to triangle GHF, so this triangle down here. We want to find the value of X. Okay, so, we did this a few different ways, but the most common way people do it is they like to do big and small or small and big. And so what I mean by that is I'll start looking for size that match up. So if I'm looking and I see that F and E and F and H go together. So FE is 90 and then HF is 27. So we're going to say 90 over 27. That's small, that's big over small. And that's going to equal the other big. Well, the other big one is 9x minus 13. And I want to put that in parentheses because it's a binomial, it needs to stay together. And then that's going to be matched up with 15. Okay, so now here, if you remember what we did a butterfly method here. So cross multiply. So 90 times 15. So I'll get the calculator out here. So 90 times 15, that gives me 1,350, and that's going to equal, I got to do 27 times both of these. So I'm going to do 27 times 9, 243, so that's 243x, and then 27 times 13. So 27 times 13 gives me 351, but it's subtract, so subtract 351. All right, now all we're doing is solving for x. So add the 351 to move it. So that's going to be 1,701. So I'm going to move this over here. Is equal to 243x. Divide by 243. So do need a little help here. So 1701 divided by 243 is 7. So x is equal to 7. Okay. So similarity is just telling us that these triangles are related. There's a value that can make all this be similar to each other. Here we're going to go same situation. So I always like to stick with big over small. And so we start thinking about the big triangle and the small triangle. And we look and we say, all right, PQ is this one, and TS is that one. So the bigger triangle is 7x plus 2. The smaller triangle is x plus 8. And I'm going to put both of those into parentheses. And that's going to equal PR. So PR and 14. 35 is bigger, so 35 over 14. All right, I'm going to do my working over here this time. So I need to multiply. So 35 times x would be 35x, and then 35 times 8 as well. So clear, 35 times 8, 280, so plus 280 is equal to, now I'll need to multiply these. So 14 times 7, 98x, and then 14 times 2, I know that one is is 28. So we need to get our like terms together. So I'm going to move the 35x over here to the 98. And to save myself some time, I'm going to go ahead and subtract the 28 from here as well. So that makes 0. 280 minus 28 is 252. And that's going to make 63x. And that's going to make 0. So now divide by 63. Just good old algebra problems here. So divide by 63, and I get 4. So x is equal to 4. All right, one more. Now here we have overlapping triangles. So what a lot of students like to do is they prefer to redraw them. So we've got the bigger triangle, which is KJL. Think about KL, that is 4x minus 12, and then 2x plus 9. And then I got this small triangle, which is MNL. So MNL. 24 and 21. Okay. So we still want to, this time we want to find out what JL is. In order to know JL, we need to know X. So we're going to stick with our big over small. So I think we can see that this one matches up with this one. So 4x minus 12 over 24. And that's going to equal 2x plus 9 over 21. All right, so cross multiply again. So we'll go here. So 24 times 2, that'll be 48x. Not sure. We'll go here first. So 24 times 9, 576. And then we need to do the other cross multiply. So 21 times 4, 84. X, and then 21 times 12. 252, but it's subtract 252. Okay. So very much like this one, I'm going to move the 48 over to the 84. So minus 48x, minus 48x. And again, to save myself some time, I'm going to go ahead and do the other one as well. All right, straight down. So 48, that's there. 8, 12, 828 is equal to 84 minus 48. 36x, and that makes 0. So we're just going to divide by 36. So 828 divided by 36 is 23. But we're not done because we wanted JL. So I come back to JL over here, which is this one. And we're going to say, all right, I want JL. So JL is going to be, used to be 2x plus 9, but now it'll be 2 times 23 plus 9. So 2 times 23 plus 9. 2 times 23 is 46. Add 9 more, 55. Okay. Next section is we want to prove triangles are similar. There's 3 ways to prove it. So you got AA, which is angle, angle. All right. Then we have SSS, which is side, side, side. And then you have SAS, which is side, angle, side. So these are our 3 ways. Okay, so now this is not congruence. Now this is similarity. So again, similarity, we have to think about different sizes. All right, and so here I've got all sides. So no angles, so it's going to have to be SSS or no. And so again, we like to do the big over the small. So 21 is the biggest and 15 is the biggest. So we're going to say 21 over 15. All right. Now the medium and the medium, so that's 11.2 and 8. So 11.2 over 8, and then 7 and 5. So what I'm going to do is I'm going to divide all these, and if I get the same answer, then they're similar. If I get different answers, then they are not similar. So here we go. So 21 divided by 15 gives me 1.4. So we have 1.4 right here. 11.2 divided by 8. That is also 1.4. And finally, we have 7 divided by 5, and that is also 1.4. So we call this the same scale factor. So that means the answer is SSS. So all 3 sides use the same value. All right, number 5, we're looking for angles this time. So I see that these are parallel. So I know that Z belongs to the small triangle and the big triangle. So Z works. And then since these are parallel, this angle is going to match that angle. So these match, these overlap. And then actually these here also work. So angles are matching up. So this is A, angle. Okay. All right, so you got some problems here to do. So remember your choices are AA, SSS, SAS, or not similar. Okay. All right, so let's come down. State is a reduction or enlargement. So an enlargement, that is going to be when K is bigger than 1. And a reduction is going to be when K is less than 1. So 3 is bigger than 1, so that's an enlargement. 1/3 is less than 1, so that's reduction. It's going to get smaller. 5/4, numerator is bigger, so this is enlargement. And then that's smaller than 1, so that is a reduction. All right, so we want to determine whether the dilation from A to B is a reduction or enlargement. So from A to B. All right, so A to B got smaller, so that is a reduction. So smaller. And now we figure out how much. So A was 1, 2, 3, 4, 5, 6, and this was 1, 2. So that's 2. So 2 over 6, that is 1/3. So 1/3 is our K. Or do one more. I think A to B, that's bigger. So it is an enlargement. And now how much? So 1, 2, and then 1, 2, 3, 4, 5. So since we're getting bigger, that's going to be 5 over 2, or you can say 2.5, either way. Okay. All right, so if we turn the page, you've got some old test questions related to these topics. Most of them are multiple choice, some of them are not, but do the best you can, and good luck.